Good morning, girls. It's not Wednesday, it's Thursday, but today I had a test, so yesterday I had to study for that test. And I didn't really feel up for it because I'd studied like all day and then I was completely empty in my head. My head was completely empty and at the same time completely full of new information. So I didn't really have the time or energy to do a video, so I apologize, but I haven't seen anything from you guys either, so I don't know. Anyway, it's the week 2 of Education Week, and I thought that today I would go through different systems in the brain, because last time I talked a little bit about, a bit more generally about what the brain was all about, but today I'm going to talk a bit more specifically about certain parts of the brain, like certain parts that I really like. But I wanted to go through a bit of the senses as well, or at least the senses that we got to know a bit, a lot about. We got to know a lot about the senses. So we are going to go through seeing and hearing, or rather the eyes and the ears. Um, so if you remember I don't know if you did this in high school, but just to keep you updated and to prove that I know this stuff. So let's start with the eyes. I did a rough sketching about what an eye looks uh, like this. So you have the cornea, which is this part, which is really hard and tough, and it's basically the glass container. The cornea is basically just what keeps your eye protected, and it is shaped like this. And then right here, where I'm pointing right now, you have the lens, which is flexible, so it can let different amounts of light in. And I didn't know this, but it's actually stretched out. There are muscles stretching it out, so when it's relaxed, it's like a little marble of gelatinous goo. So when it's late at night and your pupillae opens it to let more light in, it's actually stretching your muscles and the lens. But when you have a lot of light coming in, your uh, lens relaxes and lets less light in, or when you go really close to read something. Anyway, um, so light comes in here, and then it breaks through the cornea and the lens, and then it goes back here, and it goes through a different system of things, but eventually it ends up in the retina, where it actually is uh, captured by photocells. I don't really remember what they're called, but they are captured, and then that information is sent into it's transformed into a neural signal that goes back through the thalamus that we talked about last time and back to the occipital lobe, where it is processed and translated and then pushed up to the parietal lobe, where it's actually turned into useful information. Interesting thing, the eye actually breaks the images so that the images that come in from this angle turn upside down. So the images you see are actually upside down before your occipital lobe turns them around. And that happens back here. It's not something that the eye does, but it all happens back here. And then it's moved up here. It would be very I don't know if people who have problems with their occipital lobe actually see things upside down, but that would be really strange and annoying, and I don't know, they'd be like that kid from Family Guy who's an upside down face. Anyway, moving on to hearing. You can't spell hear without ear, and I'm sorry about that. This is basically what an ear looks like. You have the outer ear right here, and then you have the middle kind of, we called it a trumpet, but I don't know if that's what it's called in all the languages. But it's basically the channel that the air goes through, and then you have um, the little drum lid that actually captures the air pulses that is your voice or music or noise in general. and then these little bones amplify the music or noise, and then this seashell lookalike actually they amplify it, and this little seashell looking thing turns it into uh, neural signals. And it's actually quite interesting because, as you can see, I think Vihart did a video about this, in information that has really, really high vibration, like really, really high sounds, is translated back here, like right at the beginning of the seashell. But things with really low frequency has to go all the way into the ear. I think we had here at 20,000 hertz here, and here we are here at like 20 hertz. And that's the range of the human hearing. And you have this little basilar membrane in the seashell that vibrates, and then you have little hair. It vibrates like this, and then you have little hairs that break back, and when they do that, they send out a signal that goes through a complicated network of nerve cells, and then they turn up, and then they go into the temporal lobe where your hearing center is, and then that goes up to the parietal lobe where it's all melded together. So now I was going to talk a bit more about just the brain in general, and some cool things about the cerebellum, and a little bit about the limbic system. So let's start with just the brain in general. There was some things I actually forgot last time. I forgot to mention that this is a drawing of the brain I did. That is the cerebellum. This is where all your movement is calculated. So you do a little bit of movement here, the movement calculations in your motor cortex, but all the movement that you have sort of learned to do as a habit, like riding your bike or walking, is translated back, put in here. And an interesting thing about the cerebellum is that this little part of the brain that is like not even an eighth, well, maybe an eighth of the brain, like a seventh. Anyway, this little part of the brain has the same amount of nerve cells as the entire rest of the brain. So both the cerebellum and, I don't know if you understand my meaning, but this little thing contains as many brain cells as this whole thing put together, if you don't bring the cerebellum in. And that's pretty cool. That's also why if you have a damage to your cerebellum, you can look like you're drunk, because the little motions you do to correct your walking doesn't really work, because the signals doesn't go to those muscles that work without you thinking about it. So if you have damage to that brain, you might start walking strange because you don't really do all the little corrections that you need to do. And I think that's pretty interesting. So if you see someone who's stumbling around, they might not be drunk. They could just have been subjected to some cerebellum damage. Wow, that sounded pretentious somehow. Anyway, I wanted to talk a bit more about the limbic system, but yeah. I don't know if we should do this a third week. I mean, you guys haven't really put up anything, so maybe I'll give you another chance, and then I can talk a bit more about how the nerve cells work, because I really want to do that. But that's just something that came to mind right now, so now I'm going to tell you a bit about the limbic system. So, this is the limbic system. It's very poorly drawn, but it's basically this little bit here, and then it goes back and up and over here. It's like I said, it's pretty much the core of the brain, and the little bits that are actually a part of the the limbic system are the hippocampus and the amygdala. These are the things I have talked about, at least. The amygdala is very interesting. So is the hippocampus, but I talked a bit about the hippocampus. It controls memory, and I don't think it does much else. But the amygdala is very important because it controls your emotions. It's very interesting too. And um, it actually can trigger these sort of primal impulses in you. So if you see a barking dog or like a huge bear coming towards you, before you can even process that a bear is coming towards you, up here in the more sophisticated part of the brain, you know, the neocortex, the ones that actually do the thinking, up here in the frontal lobe, the amygdala has pretty much already done the decision for you, because the neural signal goes up and into the amygdala before it reaches the brain. Or there are two signals, one that goes to the brain and one that goes to the amygdala, but the one that reaches the neocortex reaches it a lot of time after. I mean, like milliseconds, but still, milliseconds is a lot when you talk about the brain. So your decision has already been made. You just have to think about it. So when you're scared is pretty much the only thing the amygdala actually does, but it controls lust and fear and anger, pretty much primal emotions. So it controls fear in that way that you can either fight or flee, fight and flight you talk about a lot, or freeze depending on the situation. But sometimes you think you see something or hear something dangerous, and then you freeze or you run away, and then you realize, oh, it was just a doll, or it was just the wind, or it was just my cat. Bloody cat, always scaring people. So you can actually start calculating, oh, it was just a cat, but the brain is already, the amygdala has already done that decision for you, so you actually started to do things. So it's more of an impulse-driven thing than the rest of the brain. And it has a lot of funny chemicals, which I might talk about next time too, because I might go through the nervous system, and transmitter substances are actually quite important when it comes to the nervous system. But yeah, that was really all I had to say. I think I might go through the thalamus too. I already did a lot about that, but it's really interesting, and it's sort of what makes your brain work, and maybe the basal ganglia. But today I went through the hearing, seeing, a bit about the cerebellum and the amygdala. So I hope at least that you feel educated, and that I see you sometime soon, because I'm starting to get a bit worried. I hope you're okay. But until then, don't forget to be awesome, and I will see you when I see you, I guess. Goodbye.